Hey guys, how's it going? We are back with another video, and today we are doing some Advent of Code Day 2. So if you're not familiar with Advent of Code, it is an annual Advent calendar where you're given a problem, and while you could do it by hand, it is much easier to do it by code, to automate it, and every day you have two problems. The second is an expansion of the first. It's harder, but you can use the first in some capacity for the second. And so in day 2 of this year, our task is simple. Given a sequence of numbers, it is considered safe if they're all either ascending or descending. So 1, 2, 3, 4, 5 would work, 9, 8, 7, 6, 5 would work, but 1, 5, 1, 5, 1 would not work because 1 to 5 is ascending and 5 to 1 is descending, and so on. The second requirement for a sequence to be safe is that the numbers have a maximum difference between the two of 3. So 1, 4, 5, 6, 7 is safe because the highest difference between any two values is between the 1 and the 4, and it's a difference of 3. But 1, 6, 7, 8, 9 would not be safe because the highest difference is 5. So while you can program this in your favorite programming language, I decided that after programming this in C#, my favorite language, I would try to build this in Minecraft. And now, I am not great with redstone, usually. This is probably the most complex thing I've done, and it's taken me a while to build. Now, I put the rule for myself that I have to build everything myself, or every component by myself, before I'm allowed to look up a more compact or more efficient way of doing a calculation. For example, I have this decoder here, which takes in a barrel input and creates the binary version of it. So I put a 5 over there, and the binary output is 0, 1, 0, 1. My version, I've since torn it down because that thing was massive, was slow, really. So since then, I found this iron block looking structure, component, I guess, and I will link the video for that in the description. Similarly, I implemented a full adder, but it was also large and inefficient, and I found this more efficient version also on YouTube, and I will link that as well. The third piece is the comparison, checking whether one number is greater than another one. This tutorial was from 12 years ago, interestingly enough, and it mostly worked. I did have to change it ever so slightly after the fact, but it works. So let's put a little bit of demonstration here. So by default, all these values are 0. So the sequence is unsafe because they're all, none of them is increasing or decreasing. So let's try 1, 2, 3, 4, 5. And the value is considered safe. They're all increasing. The greatest difference between two consecutive digits is, what's the word? 1. So let's replace a 3 with a 6, and suddenly the first 3 values are increasing, the last 3 are decreasing, and that is considered unsafe. Even if, in addition to that, the difference between these two was 4, so it was a little too high, and now we can verify that even if it's within 3, this is still increasing from that side and decreasing from that side, which makes it unsafe as well. So let's try the reverse now. Let's do, instead of increasing order, we'll do decreasing order. This is already a 3, but I'm going to replace it anyway. 2 and 1, and it flickers for a moment just because of all the repeaters in here that's creating a delay. But as you can see, it is safe still. So now let's show off that every comparison also works properly by doing a 9 over here, which makes this unsafe, an 8 over here, which makes these two safe, but now these two are unsafe, which is still false. Here we have the 7, these two are now safe together, but these two are now unsafe, so it's still false, and so on. It continues to be unsafe. So this works by first taking this input, making it into its binary form. I'm going to go into spectator mode to show you a little bit more in depth in this. Every value from this redstone repeater is encoded such that it has a redstone torch to deactivate the appropriate lines and create the binary output for this section here. This is also all color coded by digit or by operation. So we have this red line that splits off into two sections. The first part that we look at is the inversion. You cannot do easy subtraction in Minecraft. If you want to do subtraction, instead of doing 7 minus 4, you do 7 plus the 2's complement of 4, and then you ignore the last digit. So that's what this first set of adders does. The schematic has an extra carry digit at the bottom, which I've locked to be true for every row here, and this will increment the value that we plug in here, and the value we plug in here is the inverse of the value that's coming out of here. So as you can see, this is 1001, but when we feed it into this, it's 0110. So when we increment this, this gives us the 2's complement, which we then run the addition of that with the next digit over, which this we just feed directly across. This happens for every sequence of digits, but we don't care about them all. If A is greater than B, we want A minus B, and we want to ignore B minus A. So we carry the signal that was outputted from this comparison. We carry that signal all the way to the appropriate adder, or I guess subtractor would be the better term for this. And in order to get the ones that we only care about, we create the AND, we take the AND of the comparison and the subtraction, and if it's active, then that means that the distance between the two digits is greater than 3. We only do this by checking if the 4 or 8 bits are active, because those are required for it to be greater than 3. And so we just OR all these signals together at the end, and we pump them into the machine. And if this statement is true, if this redstone signal is active, the frowning face, the unsafe symbol turns on, this redstone block gets depowered, or this piston gets depowered, pulling back the redstone block and deactivating the true. And so this is day 2, part 1 of Advent of Code. Now the Advent of Code also takes in a whole slew of numbers. You'll have several hundreds of inputs, which is why you would want to do this programmatically instead of by hand. As you can see, I only have one sequence here, and that's because I wanted to make this purely redstone based. I didn't want to have a massive counter through command blocks. I didn't want to have to pump commands to fill in all of these for every input. So this is more of a proof of concept of what you can do for Advent of Code in Minecraft. Thank you so very much for watching.